This week's episodes were brought to you by the generous support of Andrew Henninger. Hey folks, Quilly here, and welcome to another Unity programming tutorial. We're working on our base building game today, and we are going to be doing some more work on our new furniture code so that we can have furniture that does something other than just sit there. Mostly, in this case, we are talking about a door. Let me go and just revise here. We do have the ability now to build a door there, and I could build one over here and then just put a wall over here to encourage my person to move. The doors do act as furniture. They do show up in here. They currently block movement because they are basically, they have the same value as a wall. In other words, they say that they currently block movement completely, so we can't cross through doors. You'll also notice that this one, it looks kind of silly sideways. We are not going to have doors be something that we kind of manually rotate in place. Instead, when we place them, the doors will correctly rotate just so that visually they look appealing. But functionally speaking, whatever way the door looks, whether it's vertical or horizontal, is going to work exactly the same. So we'll worry about the graphical side of things in a little bit. But there are actually a couple of things we need to work on vis-a-vis serialization right now that is currently broken. First of all, with this new sort of model that I put in sort of accidentally last time, and honestly, most people in the comments seem to be of the opinion that actually this should actually be kind of okay, and should work, and which is kind of weird. But I don't know. I haven't fully decided yet if this is what we're going to stick with long term. But let's go with it for now. If it's working now, we will continue on. But we did this sort of setup here with this dictionary to hold some additional parameters, a set of actions here. This is sort of implicitly an array of actions that to run during the update, and then this example of an update function. Now, we currently don't call this, which I mentioned in the last video, but it wasn't clear when I said, oh yeah, we're not getting the output from the furniture. I knew that's because we're not calling update, but I suppose we could go ahead and put that in at this point. There'd be nothing wrong with that. In our world function over here, we do already have an update function here, which calls update on all of the characters. I suppose we could go ahead and just go and call update on all the furniture and confirm that that is working, although it absolutely should be. Furnitures, and then f.update. And if we do that, it should now be running this furniture update furniture actions sort of static class, just a dummy placeholder. This represents stuff that will probably come from a text file later on. A lot of people are excited about Lua, some people are excited about Boo. This is like a way far thing. We're mostly just future-proofing at this point, assuming we stick with this implementation, which I'm not 100% sure yet, but we'll see how it goes. But now when we run it, assuming we have any doors, this should output to the log every single frame. So let me go ahead and start anew here. Hit play. Get our regular pathfinding test. Let's go and build a door, and let's watch the log. And there you go. It spams the hell of a log with those log commands. So this is definitely running correctly now that we're actually just calling that code in the world. So that's groovy. But we are missing something. Right now, these furniture parameters are not being serialized. They are not being saved out to our game data. Right now, we are just serializing out like the movement cost, basically. Well, we're serializing out the X, Y, and object type information here, as well as the movement cost. We're only reading it in because actually the world read XML, where's that? Right over here, for our furniture, is having to grab the X and Y and the object type immediately to be able to instantiate this piece of furniture, which is actually making me wonder if our write XML here, when we write out the furniture, if this might be the right place to go and put this X, Y, and object type stuff, just to be consistent. But yeah, let's not worry about it. But what we are not doing is we're not writing out, nor are we reading in this dictionary information. But not only that, there's actually a bug in our serialization code, which I hadn't noticed until I started to sort of like think about what we're going to do in this episode. The bug is interesting. We don't notice it in our test run, right? If I hit pathfinding test, and let's say, I don't know, build a couple of walls there, and a door over there, and then another wall over here, right? And if I hit save, and then, I don't know, we go new or whatever, just to show, and then I hit load, everything seems to come in fine. But I will show an example of an error. If I were to hit new world, and let's say I just build some floor down here. I have no furniture. Let's save, and now let's load. You'll notice my character is missing. There's no character here anymore. But if I go and create the floor and put at least one piece of furniture in here, and then hit save, and then load, then everything is fine. And the reason for it is, right now, the way we're looping through our XML file, so let's say when we're reading specifically. It's not a bug with writing, it's a bug with reading. When we're looping through our XML file here and we're reading basically one tag at a time, one element at a time here. And then we're saying, hey, if depending on the element type, do some stuff. So in this case, we're reading tiles runs, although it might be an issue as well. But in our example, where if we put down tiles but we had no furniture, our characters didn't load. Let's find out why that is. So our tiles run, and presumably they run fine. Then it goes and hits our furnitures tag, and then it calls the read XML furnitures. Well, read XML furnitures, what it does immediately is do a while reader.read. It reads the next tag. And then presumably, so we're inside the furnitures tag, and presumably the next tag inside of that is supposed to be a furniture instance. And then we loop through all of those. Now, if the next tag is not a furniture instance, what actually ends up happening is this will read the closing tag of our furnitures, which then is not a furniture. So it dumps us out of this, which means we are back in read XML. It goes through this next while loop, reads in the next one, and we end up with characters. But if this is empty, what happens is the way the first read over here reads the line of furnitures, the furnitures tag, because it's empty, there's nothing inside of it. The next read here, this read actually dumps us onto characters, our characters tag. And that happens here, which then exits this function, which goes here, and then we go reader.read and we read the next tag, and we're not at the characters tag anymore. So what we're doing is we're not going through this file quite correctly in the case where one of these tags ends up being empty. Now, generally speaking, that won't be the case, but it will be an issue with our furniture if we are trying to write. So right now, our furniture tag just basically looks like this. Let me put in a comment. It looks like furniture x equals, whatever, y equals whatever, object type equals wall, and movement cost equals 0. And then it probably is using a self-closing tag because it has no content. And that's probably a standalone tag, as opposed to what we're going to sort of want once we start writing up parameters, right? We're going to have something like, I don't know, param, name equals openness, that's mostly for doors, not walls, value equals 1.0. Something like that. I mean, we could have the value be in the content, but let's assume we've got something like that. Again, let's assume it's sort of a self-closing tag. And then there's a bunch of these, and then we're going to close the furniture tag. But if we have an object such as a wall that has no parameters whatsoever, right? No parameters, then we're back to the sort of self-closing version or something of that nature. In any case, it'll cause our writer to sort of skip ahead in an inappropriate way, exactly the same as if we have no furniture. And it's entirely conceivable that someone could save a map with no furniture, and all of a sudden when they reload it, their character's not there, which would be bad. And the same thing will happen if there are no tiles. It'll bug out. So the way we fix this is, instead of just doing a while reader.read at this point, instead we are going to use an explicit check for descendants and siblings. Okay, so we are in a tiles element, so read elements until we run out of tile nodes. So what we're going to do is we're going to say, first of all, we're going to ask the reader to look for a descendant. We're going to read, not just do a blind read, we're reading until we hit a descendant called tile. Okay, so right now we're in the tiles tag, and we're going to read until we hit a descendant called tile. And this will return Boolean, just like this. Reader.read will return false if it ever runs out, if the file ends. But this will return true or false based on whether it found a descendant called tile. So first we can sort of wrap this in an if. Now we can't, this is not a while here, right? Because we're in tiles, we're going to read to a tile. And only if there's a tile at all are we going to do stuff, okay? We have at least one tile, So do something with it. And what does that do? Well, we are going to just read in that data. Let me actually get rid of this old code completely. Okay, so now we know we've read to a descendant. We know for sure we have a tile descendant, and we do that. If there's no descendant tile, this returns false right away without actually moving where our reader is, which means we won't get that issue. Now, this is only going to read in the first tile. How do we read in the next one? Well, again, we could do, actually at this point we could probably do reader.read, because the worst case scenario here is that it dumps us to the closing tag. And again, we could do one of these checks for reader.name. But instead, what's going to be better is to use reader.read to next sibling. We're going to make sure that we're reading to our next sibling, like within the same parent of tiles, we're reading to our next sibling called tile. And we're going to make that explicit. And this is going to be, so this is a loop, right? We need a while loop. So rather than use a while loop, we're going to use a do while loop. Because, and this is not, I don't use it often, and then I don't never think about it. The difference between this and a while loop is that a while loop won't execute at all if the first condition isn't true. And usually that's fine, but in this case, the condition here is not something we can test on the first go. So we use a do while, which guarantees it runs at least once, because we know at this point, based on this, we are now at the right place, so we read that in, and then while the next thing continues to be a tile. Anyway, we're just going to copy this structure down here. So we are going to say, basically, if reader.read to descendant called furniture, then we don't need to escape this way, which is fine. And then do while reader.read to next sibling called furniture, and then close that up. And finally, the same thing with character over here. If reader.read to descendant character, whoops. And this is just the correct way that we should have done from the beginning. It happened to work because we just happened to have data in there correctly. But this will work the same way and will be much more robust. While reader.read to next sibling called character. Boom. All right, so let's verify that this code works as before, and that will be assisted by me not making any syntax errors. We need to close that. There we go. Hit play. So let's first get the generic map up, try to save this, and now try to load it. Looks good. Now let's get a new world that is empty. We're going to try to save this, and then we're going to load this blank world with our character, which is great. Let's add a floor but no furniture. We're going to save this, load this. That's great. Let's try to build a single wall, save it, load it. Awesome. Everything is working beautifully. And we're going to apply this same little structure to our furniture as we go and save our parameters out. And we are going to hit a bit of a snag here. So overall, I'm kind of starting to dig this. We have to move it. I don't like where it's positioned and how it's not commented. We're going to figure out a better way of organizing it. But we are going to run into one quick little issue here, particular with our furniture parameters as we start to serialize this. So here's our write. We're writing in our basic data on our current tag, which is fine. And then we're going to go and start, so writer, and we're going to go begin, oops, what is it? Write start element. We could do one with params, but I don't think there's any reason to do that. I think we could just go and say something like, for each string k in fern parameters dot keys, we'll just make an element inside of this called, say, param. And then right away, so we don't forget, do the write end element like that. So we'll open and close this thing, which is fine. And then in here, we're going to say writer.write attribute string name. And the name of the parameter will be the key. And then here's the tricky bit. We're going to say write attribute string value, and we need to write the value out in some fashion, right? Which, sure, is as easy as doing this. This. The problem is, what is the value of this parameter? Well, right now, we're allowing us to stick any object in there. And how do you output any object? Well, I mean, presumably it's got, hopefully you've got some sort of two-string representation of that. But then you're sort of praying that it works. And then how do you deserialize it? When you're reading it over here, do you just take in the string and try to stuff that in? Well, no, what if it's supposed to be a float? Well, you want to parse it to a float. What if it was supposed to be a Boolean? What are you going to do there? We run into our first little issue with this. And again, I may not be keeping this. I think for now, it is probably fine if we do something as simple as, let's assume they're all supposed to be floats, all the parameters. I mean, certainly you can use a float to represent a Boolean, right? A value of 0 is false, a value of 1 is true. That works. I mean, integers basically map to floats perfectly fine, so that's okay. Is there any reason we would want the this furniture parameter to be storing a string value instead? It's kind of hard to imagine anything but something arbitrary. Push comes to shove, we could always have two of these dictionaries, one for floats and one for something like a string. Let's just go with this for now. Again, I'm not 100% locked in here because things are still a bit fuzzy in my mind. But let's just go with this for now and see what happens. So let's assume these are going to be floats. Okay, well that's fine, because a float can be written as a string that's got, rules for that, which is just perfectly acceptable. So we'll write those elements. And then here when we're reading it in, we're going to have our same structure as before. If reader.read to descendant called param, we're going to make sure that we have at least one parameter. Then we are going to do, and what are we going to do? We are going to grab the key, which is going to be reader.get attribute name, and we are going to grab the value, which is a float. So we can go float.parse. And again, if float.parse fails, it will return an exception at this point. We're currently not testing for those, but we will do that in the future once we decide what are we going to do once there's an exception. Right now, we'll just let it we'll just let Unity freak out and tell us that there's an error. Later on, we'll want to deal with that gracefully and tell the user, oh, your save file is corrupted, we can't read it, sorry bro, or something of that nature. But for now, it's fine for Unity to basically just give up and die. So we are going to parse reader.get attribute value. We're going to parse it into an integer. Apparently I figured out a T, that's why it didn't autocomplete. So we're going to grab both of those, and then in our furniture parameters, we're going to say k is equal to v. And then while reader.read to next sibling called param, like so. All right, so that should read them all in. And the fact that none of my furniture has parameters right now. Oh, right. We have other references to, say I switched it to this fern parameter being a dictionary of string, comma, float. And some bits still have references to string, comma, object. There's one more. Where is it? Guess I could have just hit F8 to compile there. There it is. There. They're all string, comma, floats now. Cannot implicitly convert. Oh, this is supposed to be a float. Oop, not a string. There we go. Okay. So even though our save file right now doesn't have any params, we're okay with loading in furniture that doesn't have parameters. There we are. That works fine. Let's get a map we're happier with. Actually, let's make a new world. Put down the pathfinding test. Hit save. Actually, let's build a door. And actually, to prove that this is not taking that, let's load. And this will be the version without the door, and the character's still standing there. So let's once again build the door. Then we're going to drop a wall there and there. And actually, I will save before he gets to the wall. So now if we load, the wall is not built. Perfect. And we are currently not saving jobs to the save file because we know for sure the job data is going to change dramatically in the near future. And so there's no sense in writing the code to save that out right now. Okay. So that's great. And right now, none of the things have parameters, but if they did, they would be written out and then they would be saved as well. The one thing is we do instantiate that correctly. Yeah, we do. Okay, so this dictionary will never be null, and that'll be fine. So we'll write those attributes in there. And right now this is public, although it's certainly easy for us instead of having this be public, these could be protected or private, and instead we could have some functions to access this back and forth. But let's leave it public for now until we figure out what we want to do with it later. Okay. Ooh, we're nearly out of time in this tutorial, so let's talk about how we're going to deal with these doors. So right now, I can't walk through a door. So if I say, hey, build a wall over here, it won't work. And in fact, we currently just generate a bunch of errors because things are being queued and requeued. Yeah, so let's deal with this. Something's a little bit off. Something's a little bit off. On job created for a job go that already exists. Most likely a job being requeued as opposed to created, which is fine. Oh. We should be doing this. It's because I was like, that's fine, but I still notice the inspector is filling up the game objects. Why is it? Because the game object gets created right away. We need to move that until after we check. First, if it already creates a job, then there we go. So let's not generate an error for it. Well, I mean, it's fine. The reason it's spamming the log here is because it puts it tries to make to find a path to the job site, and then it can't. So it requeues it, and then on the next loop, it just grabs the first job from the queue, and again tries to path to it over and over and over again. And it's because onJob created is called for anything that gets in queued, even if it's not, a real thing. I guess I could go. I don't know what we want to do with it. I suppose it's fine that they get spammed in there. The fact that the game objects were being created was a bug, but the fact that the current behavior is not a bug. It's just a fact of the matter that this is the way it's working. We grab a job off the queue, we realize we can't reach it, we requeue it, and then the next frame we grab a job off the queue and it happens to be the same one. See, all of a sudden we won't get errors for a little bit, and then we're going to start getting errors again as it's just grabbing the same job over and over. Everything's working as intended. It's not working the way that it's going to work in the end. But, okay, so we can't go through doors, which obviously we need to be able to do. Now, the reason we can't go through doors is because way over here, when we create our prototypes, we say, hey, the movement cost to go through a door is 0, which is our code for saying you can't walk through it. If we had a 1, this would be a normal value. We could say walking through a door has a movement cost of 5. It takes longer to walk through a door. Now, right now, I actually don't know if our speed gets modified by that. Let's see what happens. Let's set it something high, like 50. Now, at 50, the pathfinding system should take into account the movement cost. And so it means it would prefer not to walk through a door, if possible. Hey, let's try that. Let's build a floor. Let's get some doors across here. Oh, the doors are linking up, because I say that the doors link to neighbors, which is not true. But because it's trying to link to neighbors, it's trying to come out with slightly fancier graphics, which don't exist. Just like the walls, right? Although it should have defaulted to the base one. We'll have to see what we can do about that. Okay, so again, let's drop down the floor. Let's get a list of doors over here. Eh? One door. Since when do you not work? You were working a second ago. Okay. Key not found exception. Given key was not found in a dictionary. So where is this error happening? It's happening at Furniture Sprite Controller, line 96. So how come the graphics were working a second ago? It's looking for a slightly differently named door. Oh, I think, okay, so the first set of errors was because it was looking for doors that were connected to neighbors, which need particular naming. Now, because we said it doesn't connect to neighbors, I think it's just looking for a door called door, not door underscore. Let's test that theory. Apply that. Hit play. There we go. So that works. So now we'll get a string of these doors. See that? Let's build a wall here. Now let's build a wall up here, and he should walk around the doors. Because these doors have a movement cost listed of 50, which is very slow to walk through. Now, they will avoid the doors, but if need be, he will walk through them because there's no choice. So right now, the pathfinding system is taking into account the movement cost. Let's go, for the sake of argument, go to our character code, and make sure that our character is paying attention to the movement cost. So right now, and the movement cost is the cost to enter a tile, is the way we've decided to do it. Leaving the tile, you can do it full speed, but entering it takes the time. It can look a little bit funny, maybe, when you're standing in a tile and you leave and it's very fast. But I think logically, people are going to have a fine time dealing with that. So we get the tile over here. We get the distance to the travel. How much distance can be traveled this update? And then we convert that to a percentage and then add that in. What we have to do is divide our movement speed by the cost to enter the tile. So our movement speed is being slowed down by our destination tile. We've got one of those, right? Next tile. Our next tile dot movement cost. Now, if next tile dot movement cost is equal to 0, this will throw an error, obviously. Dividing by 0 is very bad. But the problem is, or the thing is, we should never have a tile with movement cost of 0 because that would be indicative of us trying to enter an unwalkable tile. Can this happen? Yes, it can, actually. Because what can happen, imagine the case where we have multiple characters running around. So one character wants to go from one side of the map all the way through the other, and he's walking through a hallway. So he does his pathfinding, he finds a valid route, and he starts walking along there. And then a second character comes and builds a wall along that route, turning one of the tiles that the character wants to walk through into an unwalkable tile. When he gets there, our character still has that tile in the queue, and will then try to walk through that tile, and then generate an error. Now, when a new wall gets built, it does invalidate our pathfinding graph. I don't think we actually check for that here. If the graph has been invalidated at some point, we just assume that our path is still valid, which most of the time will actually be fine. We're gonna have to come up with some sort of rules for reevaluating whether a path is valid, like every so often or whenever a wall gets created. We'll have to see, exactly how costly those operations are, and we'll decide how frequently to do it. But for now, let's go and put in a little check right before this happens. If the next tile.movement cost is equal to 0, then debug.log error fix me a character was trying to enter an unwalkable tile. So then what we're going to do is we're going to tell it to abandon our path. We're going to set next tile to be equal to null, because obviously we can't enter it. But not only that, we're going to invalidate the path that we have. This is path A star is our pathfinding that we'd gotten before. Well, we're going to tell it that, hey, obviously our path is no good. So our next tile is a no-go. Clearly, our pathfinding info is out of date. So we'll do that, and then we'll return right away to bug out. But we're going to need a slightly better way of handling this later, in that it would be nice if a character never tries to enter a bad tile, because we've already recognized before he got there that this tile and this path is no longer valid, and therefore it should regenerate things. Maybe we can have this character periodically check all the tiles along his path to make sure they're still valid, or we can have some other way of flagging that things are invalid. We'll figure that out later. But it would be nice if the character didn't walk halfway across the map just to bump in a tile a new wall that was built like 20 turns ago, and then have to turn around and walk a long way around. But for now, this is going to be okay. So now we factor in this movement cost. So let's try to... I should have saved that map. Geez, we have this file saving. It's great. I should take advantage of it. Build floor. And build... You know what? Actually, well, yeah, let me create a new world. Build floor. We're going to make this a little smaller because it'll be easier to test with. Build doors along here. Build wall. And so he'll avoid walking on the floor. Whoa! Why are you trying to enter an unwalkable tile? It's because the first tile in our path is the current tile. So the question is, and see, we remember we're always getting this little thing. Should we discard the first tile? And or should path A star not return the initial tile? Right? So right over here, remember our pathfinding? So this is our A star pathfinding. And what's been happening, and the reason that all along, every time we start a new movement, we get this little log error. It's because the first node on our path is our starting node. I think it's probably reasonable to leave that off. And I think that's probably what we're going to do. Maybe we do that here. Maybe we have the character ignore that. We could do it very simply. Right? We could do, like, yeah, we can leave path A star unchanged and just say, like, let's ignore the first tile because that's the tile we're currently in. So there's two possibilities. We could change the A star to not return that, or we could ignore it because maybe sometimes we want it for something else. For example, drawing paths. We're gonna want to draw all the tiles, including the start one. I don't know. Let's do this for now. That should solve our initial problem. So now, if I do this and tell you to build a wall over here, and then tell you to build a wall over here, yeah, now you're okay with that. And then build floors along the way here. Or not floors, doors. They rhyme. Then build a wall down here, which should be fine. Now build one over here. Ah! Oh, that's interesting. The path was too short and was actually resulting in error over here. But our distance, we're not moving slowly through our, I forgot to save it again. Let me get this going properly now. Floor, make it a little longer so we can see it a little bit more clearly. Whoa, no. I did not do that, you son of a... I think there was a little bit of a lag in there and it caused this little drag. We'll have to revisit our code after. Let's do this. Wall. Wall. Where is this being called from? It's got to be that line. From 102? Oh, are we grabbing 2 tiles at a time right now? Hold on. Yeah. Sorry, my bad. Because every time we were grabbing the next tile from the queue, I was skipping one. So it was mostly looking okay, but it would not have been okay. So that should get rid of that error. And that actually might be part of the reason for that that glitch. We might have been skipping over the tile code. I suspect that's exactly what was going on. There you go. No more errors. Doors along here. Now, I'm going to hit save. So I don't have to rebuild it. Wall down here. Now wall up over here. There we go. Crawling through it at 1/50th the normal speed. So now our character has been updated to respect movement costs. I mean, he was already respecting movement costs of 0, in that our character will not walk through a tile with a movement cost of 0. In fact, it would throw up an error right now if at any point the character would try, but is now respecting the tile movement speed. It's not just the pathfinding system trying to skirt around things, but it's doing that. That doesn't actually, resolve our door issue, because of course our doors should not force characters to move through slowly. In fact, I would suggest that our doors, you can move through them at normal speed, which will happen by changing our little configuration file there. And we load our map, and I say build that there. You should now move through the door at a crawl. Oh, because we're saving movement costs. Do we want to save movement costs? Actually, I don't think we do. I think the movement costs should just come from the prototype. Yeah, why would we? No. We're not saving or restoring movement cost. If we make a change to our prototype, to our config file, these doors should now use the new value, which is exactly what's going to happen. It's going to use the value from our little prototype. There we go. So normally you should be able to walk through the door at max speed. The exception is if the door's not open. What I want is our character to sort of move up to the door, for the door to open, and then our character to be able to continue through at that point. It'll continue through at full speed, but not until the door opens up. And that's what I want to do next time. Thank you very much for watching, folks, and I'll see you then. Thank you to everyone who pledged to support this in February and is making these videos happen through March and early April. And of course, these mic check supporters. We've got Wes Eldenboving again, Craig Mortel, Nail Vikstrom, Neil Blakely Milner, Speedy Savant, Valent Cake Fiend, Aaron Toyson, Marius Field Vold, Old Peter, Talgo, probably Ole, Julian Ogier, Lafone, Steven Stager, Michael McClintock, Kale the Quick, Drazion, Bite Rash, Adjective, and Andrew Henninger. And everyone who just watches and shares and favorites and comments and subscribes, thank you so much for just continuing to make these videos a thing that we can do. I think it's pretty awesome, and I hope you do too. See you next time, folks.